Hello, hello! Here is the video going over the Unit 3B quiz review on exponential functions. So the first thing we're going to look at is actually calculating bases to exponents. So here we are evaluating the following functions. We're leaving all answers in simplified fractions, and we want to do this without a calculator. So every single one of these problems is written in function notation, so I do need to pay attention to which function I am going to use. Number 1 says f of -1, so that means I'm going to take -1 and plug it in for x into my f function. So let's do that. So I have 9 to the negative first power. Now we have a negative exponent. Anytime you are presented with a negative exponent, what you need to do is you need to flip the base. So if I look at my base is a 9. And 9 as a fraction is 9 over 1. So what I really have going on is 9 over 1 to the negative first power. Since I have a negative exponent, I want to flip the base. So what that becomes is it becomes 1/9 to the positive first power. So anytime I flip the base, my exponent becomes positive. And then I can evaluate. So 1 to the first is just 1, and 9 to the first power is 9. So my answer for this is 1/9. Number 2, another negative exponent, except this time I am using the g function. So I'm going to go ahead and plug that in. I have 5 times 2 to the negative first power. Once again, since I have a negative exponent, I'm going to go ahead and flip the base, and only the base. Do not touch the 5 yet. So that gives me 5 times 2 is the same thing as 2 over 1, which when I flip it over becomes 1 over 2 to the first power. And then order of operations tells me I have to deal with the exponent first before I multiply by the 5. So that gives me 5 times 1 to the first power is 1, 2 to the first power is 2. So I have 5 times 1/2. Well, 5 is the same thing as 5 over 1. And when I'm multiplying fractions, I can multiply straight across. So 5 times 1 is 5, and 1 times 2 is 2. So my answer for number 2 is 5 over 2. Number 3. Another negative exponent. This time I'm plugging into the h function, so I'm going to go ahead and take the 5/6 and raise it to the negative second power. Once again, anytime I am raising something to a negative exponent, I'm going to take my base and flip it over. So this becomes 6/5 to the positive second power. And then from here I can go ahead and square both of those terms. So 6 squared is 36, and 5 squared is 25. All right, now moving on to positive exponents. So I have g of 3, so that's going to give me 5 times 2 to the third power. Once again, order of operations tells me I need to do the exponent first. So 2 cubed is 2 times 2 times 2, which is 8. So I have 5 times 8, which is, if it would only write, there we go. 5 times 8 is 40. All right, h of 2, I'm going to take 5/6 and raise it to the second power. So 5 squared is 25. 6 squared is 36. And last but not least for this section, f of 0. So I have 9 to the 0th power, and anything raised to the 0 power is automatically 1. All right, next up, some graphing. So what I want to do is I want to fill out the table, and then I can use those points to sketch the graph of the equation y equals 3 to the x. Once again, we are going to do this without a calculator. So right here, my base is a positive 3, And since I'm dealing with a negative exponent, I'm going to have to flip the base. So this becomes 1/3 to the third power. Now, 1/3 to the third power, well, 1 to the third is 1 times 1 times 1, which of course is 1. 3 to the third, or 3 cubed, is 3 times 3 times 3, which is 27. So that means 3 to the negative third power is 1/27. I'm going to do the same thing, just this time my exponent is a -2. So once again, I'm going to flip my base, and when I do, my exponent becomes positive. So 1 squared is 1, 3 squared is 9. So I have 1/9. 3 to the negative first becomes 1/3 to the positive 1 power, which equals 1/3. 3 to the 0 power is automatically 1, because anything raised to the 0 power is 1. 3 to the first is 3. 3 squared is 9. And 3 cubed is 27. All right. Now we can take these points and sketch the graph. So I'm going to start by plotting the nice numbers that I can fit beautifully on my graph. So 0, 1 is what I'm going to graph first. That is right here. That's your y-intercept. Next, I'm going to do 1, 3, which is right here. 2, 9, and 3, 27 doesn't fit on my grid. And now I'm going to work my way through the fractions. So -1 and 1/3 is going to be approximately right here. And my other fractions are just going to get closer and closer to my x-axis. So I'm just going to plot some points that are pretty close to the x-axis. Of course, I don't know exactly where 1/9 or 1/27 are on the graph, but we do know exponential functions are going to approach the x-axis. So now that I have these points plotted, I can go ahead and connect them and make a nice curve. And there is your graph. If you'll notice, as I went to the left towards the negative x-axis, my line did not cross the x-axis, because it will never cross the x-axis since your x-axis is an asymptote for your exponential function. So it'll taper off and approach the x-axis, but never actually cross it. Okay, next up, matching. So we're matching exponential decay, exponential growth, and linear decay. And if there's a random function in there, that would be the neither. So if I look at my functions that are presented to me, I'm going to go ahead and start labeling some of them. If I look at letter A is in slope-intercept form, y equals mx plus b. So I'm going to go ahead and label letter A as linear. Letter B has x as an exponent, so that's exponential. Letter C is also linear because it's in slope-intercept form. Letter D is exponential because I have x as an exponent. And letter E, you know, that's an x squared. That's a quadratic. So letter E is going to be our neither. Okay. Now, for the rest of them, we need to determine if it is exponential decay, exponential growth, or linear decay, linear growth. So let's talk about the linears. So if I'm trying to determine if it's linear decay or linear growth, what I'm looking at is I'm looking at the slope. If my slope is negative, that is going to be linear decay. If my slope is positive, that is going to be linear growth. So letter A is linear decay. So I'm going to put A for 11. Letter C is linear growth. So I'm going to go ahead and put C for number 10. Now for exponential growth and exponential decay, what you need to look at is you need to look at the base. The base is what is attached to the exponent, so I'm looking at the 1/4 and the 1.6. If my base is between 0 and 1, that is going to be exponential decay. If my base is greater than 1, that's going to be exponential growth. So letter B is exponential decay, and letter D is exponential growth. All right, let's see what's next. Word problems. So for the word problems, we do need to pay attention to whether we have exponential growth or exponential decay, and we are going to start by writing the equations. Now, in order to write the equations, we need to know two things. We need to figure out what A is, and we need to figure out what B is. That way we can write the equation in the form y equals A times B to the x. A is going to be your initial value, and B is your base, but depending on your situation, if it is growth, that is going to be 100 plus your percent. If it is decay, that is going to be 100 minus your percent. And before you put it in the parentheses, we will always change it to a decimal. Okay, so here we go. A concert promoter determines that there are approximately 1,050 tickets pre-sold for the next Demi Lovato concert in Chicago. If ticket sales continue growing at a rate of 23% per day, how many tickets will be sold after 6 days? Okay, so my starting amount of tickets is 1,050, so that's my A. Now for my B, I need to determine whether it's growth or decay. Well, this tells me that it's growing, and it's growing at a rate of 23% per day. So what I'm going to do is I'm going to take 100 plus the 23%, which gives me 123%. Okay, now anytime we are writing an equation, we need to change our percents to decimals. And to do that, you're going to take your decimal and move it over 2 units. So this becomes 1.23. Okay, so now that I have my A and my B, I can write my equation. So I'm going to write y equals 1050 times 1.23 to the x power. And once I have my equation, I can go ahead and answer the question. And to answer the question, I am going to take my 6 and I'm going to plug it in for x. So in my calculator, this is what I am typing in. 1050, 1.23 to the 6th power. So let me type that in. That gives me approximately 3,636 tickets if I were to round it. Don't forget your units. Since we are talking about tickets, we need to put tickets as our answer. Okay. Let's see, a family buys a car for $20,000. The value of the car decreases about 20% each year. After 6 years, the family decides to sell the car. How much should the family sell the car? So I'm going to start by identifying my A. That is the initial value, so the starting value of the car, which is $20,000. For B, since it is decreasing, I'm going to take 100% minus the 20%, which gives me 80%, which of course I do need to change to a decimal, so that becomes 0.8. Okay, so here's my equation. Y equals 20,000 times 0.8 to the x power. So the question says, after 6 years, how much should you sell the car for? So I'm going to take 6 and plug it in for x. So I have 20,000 times 0.8 to the sixth power. So let me calculate what that is. 20,000 times 0.8 to the sixth power is approximately $5,242.88. Anytime you're working with money, you should always round to two decimal places, since money usually operates in two decimal places. All right, next up, you are going to Disneyland over winter break. You need to borrow $500 to pay for the trip. You go to the bank and borrow the money at 11% interest for 2 years. Calculate the total amount you need to pay back. So anytime we're talking about interest, interest is always added to the amount that you borrow. So my initial amount is going to be the 500, so A is 500. And for B, since interest is added, I need to pay for the 100% of the $500 plus an extra 11% interest. So that gives me 111%, which of course we need to change to a decimal, so that's 1.11. So my equation is 500 times 1.11 to the x. And it tells me I am paying for 2 years, so I'm going to go ahead and take 2 and plug it in for x. And let's calculate what that is. So 500 times 1.11 squared gives me $616.05. All right. A beehive starts with a colony of 300 bees. The population decreases by 5.5% each month. What will the population of the beehive be 9 months from now? So I'm going to go ahead and figure out my initial value. The beehive starts with 300 bees. So that's my initial value. The population is decreasing. So I'm going to take 100 minus the 5.5%. That gives me, I'm plugging it into calculator because my mental math skills aren't that great. There we go, 94.5. And these are calculator questions, by the way. And then I'm going to move my decimal over 2 units. So 0.945. So my equation is y equals 300 times 0.945 to the x. And of course, to answer the question, I'm going to plug in 9 for x. So in my calculator, this is what I am typing in. 300, oh, I was about to write 6. I want 9. So 300 times 0.945 to the 9th power gives me approximately 180 bees after 9 months. Okay, next question. Suppose you start a lawn mowing business and make a profit of $400 in the initial month. Let's call this month 0. Each month your profit increases by 5%. Your friend starts his own painting business and only earns $375 in the initial month. Let's call this month 0. But each month his profit increases by $25. Create a table for your business and a table for your friend's business. Okay, so my business starts with an initial value of 400. Okay, so we're doing it for each month, so I'm going to go 1, 2, 3, 4. Now, in order to calculate what's happening month after month, I need to pay attention to what's happening with the scenario. It is increasing by 5%. So what I have here is an exponential growth function because I am increasing by a percent. Anytime you are increasing by a percent, what you're going to end up doing is you're going to be multiplying by something. So what I want to do is I want to figure out what I'm multiplying by. So in this case, I am increasing by 5%. So B is going to equal my 100 plus the 5%, or 105%. And of course, that as a decimal is 1.05. So in order to fill out the rest of the table, I am going to multiply each amount by 1.05. So 400 times 1.05 is $420. 420 times 1.05 is $441. Times 1.05 is $463.05 times 1.05. That gives me $486.20. Now let's talk about my friend's business. So my friend's business starts with $375 in the first month, initial month, month 0. So $375. And each month after that, their profit increases by $25. So what's happening here is I am adding $25 each time. So when I'm adding the same number every single time, that represents a linear function. So let's go ahead and add 25. So 375 plus 25 is 400, plus 25 is 425, plus 25 is 450, plus 25 is 475. Which business shows exponential growth? Which shows linear growth? And how can you tell? So again, my business is exponential growth because I am multiplying by 1.05 each time. My friend's business is linear growth because I am adding $25 each time. So since I just explained it verbally, I'm not going to write down the answer. But once again, this right here is exponential because you're multiplying. And my friend's business is linear because I am adding $25 each time. So that answers letter B. Letter C, after 6 months, which person has earned more money? So if I look at my scenario, I am going to, in order to calculate after 6 months, I do need to figure out an equation for each one of these scenarios. So for my exponential function, I need my A and my B to be able to write an equation. So I have y equals, A is my initial value, which is 400, times 1.05 to the 6th power. And that is going to give me, let's see, 400, 1.05 to the 6th. That is going to give me $536.04. Or you can always continue the table. So I can go ahead and continue the table. I can keep going until I get to the 6th month if you don't want to figure out the equation. Same thing with the linear function. I can write the equation. It is linear, so it's slope-intercept form, which is mx plus b. M is what you're adding each time, which is 25. And b is your initial value, which is 375. But of course, since I want to figure it out for 6 months, I am going to go ahead and take my x, and I'm going to plug in 6. So I have 25 times 6 plus 375 is $525. So I can see after 6 months, I am going to have more money than my friend's business. All right, let's see what's next. Writing equations. So write the equation given the table or the graph. Exponential functions should be written in the form y equals a times b to the x. Linear functions can be in slope-intercept form, y equals mx plus b. So the first thing I need to do is I need to figure out what's happening to my y values to determine if it is going to be exponential or if it's going to be linear. So if I look at 18, I'm going from 1 over 49 to 1/7 to 1 to 7 to 49. Now, fractions hurt my brain, and I'm assuming they hurt your brain too. So what I want to focus on is I want to focus on these numbers here, and I want to see what's happening. So if you look, you're not adding the same number each time. What's happening is I am multiplying by 7 each time. So since I am multiplying by 7, that is going to create an exponential function. So my A is your y-intercept, which is when x equals 0. So my A in this case is 1, and B is what you're multiplying by every single time. So b in this case is 7. Now let's say you look at your table and you do not recognize that you are multiplying by 7 each time. You can easily tell that you're not adding the same number each time because of those funky fractions. But let's say I can't figure out that I'm multiplying by 7. What you can do is you can take any y value, for example that 49, and divide it by the y value right before it, and that will give you what your b is. So 49 divided by 7 is going to give you that 7 for your b. And now that I have a and b, I can go ahead and write the equation. We usually do not put the 1 there when a is 1, but you can if you really want to. But I'm just going to write it as 7 to the x. The 1 is totally optional. Okay, now let's look at 19. So if I look at 19, again, I'm not adding or subtracting the same number each time because I can see that the difference between those values are different. So 64 to 32, I'm subtracting 32, but 32 to 16, I'm subtracting 16, so that can't be linear. So in this case, it's going to have to be exponential. So again, I'm going to start by finding my a. A is my y-intercept, which in this case is 64. Now for my b, again, I'm having a hard time figuring out what I'm multiplying by every single time. So what I'm going to do is I'm going to take any y value, I'm just going to go with 8, and divide it by the one before it. So 8 over 16 is 1/2. So I can write my equation, y equals a, which is 64, times b to the x. Number 20. So if I look at number 20, I'm going from 4 to 8 to 12 to 16 to 20. Now let's say I see the 4 and the 8 and I think, oh, I'm multiplying by 2. Okay, well let's see if that continues to work in my table. So 4 times 2 is going to give you that 8, but 8 times 2 is most definitely not 12. So let's see if you're adding the same number each time. So if I look at my table, 4 plus 4 is going to give me 8, plus another 4 is going to give me 12, plus another 4 is going to give me 16. So this one right here is linear. Now when I'm talking linear, I need to write it in slope-intercept form. So again, I want to find my y-intercept, which in this case is 8, and then I need to figure out my m, because it's y equals mx plus b. Well, m is what you're adding every single time. So m is 4, and b is 8. So I'm going to write y equals 4x plus 8. All right. I think the next section is equations for graphs. Yep. Okay. So all of the graphs that you're presented with are exponential graphs. So again, in order to write the equation, we need to know two things. We need to know a and b. Well, a is your y-intercept. Your y-intercept is where it crosses the y-axis. So a in this case is 1. Now, b is a little trickier to find. So in order to find b, what I like to do is I like to take my points and actually create a table out of these points. That way you're doing the same exact thing you did with the other problems. Just make sure your x's are in numerical order. So -1, 0, and 1. -1, my y value was 4, 0 was 1, and at 1, my y value was 0.25. Okay. Now, once again, I need to figure out what b is. And in order to figure out what b is, if you don't recognize what's happening, is you can take any y value and divide it by the one right before it. So 1 over 4. So now I can write my equation, y equals a, which is 1. So once again, I'm not going to write the 1, but you can if you really want to. b is 1/4, so I have y equals 1/4 to the x. 22. Here is my a, so my y-intercept is at 3. And once again, I'm going to go ahead and create a table just to organize my points. So I have -1, 0, 1. At -1, that's 1.5. At 0, I'm at 3. And at 6, and at 1, I am at 6. And to figure out my b, I'm going to take any y coordinate and divide it by the previous one. So 6 over 3 is 2. So I have y equals a times b to the x. All right, last two graphs. Y-intercept. For my b, I'm going to set up a lovely table to organize my thoughts and my points. -1, I'm at 0.2. 0, I'm at 1. And then 1, I am at 5. And to figure out my b, I can take any y value and divide it by the one right before it, which of course is 5. Now, by the way, you can also do the other y values. So I could have done 1 divided by the one before it, which is 0.2. If I were to put that into the calculator, still going to give you that 5. So my equation is y equals a, which is 1, times 5 to the x power, since my b was 5. All right, last question. A is 3. B, I'm going to set up my table. Table's totally optional, by the way. I just like to organize my points because it's easier for me to see what I'm going to divide by. So -1, I'm at 12. 0, I'm at 3. And 1, I am at 0.75. And when I'm calculating my b, I do like to avoid my fractions or decimals just because, you know, I like whole numbers. So I'm going to go ahead and pick my 3 and divide it by the one before it. So 3 divided by 12 is 1/4. You are always dividing by the one before your y, by the way. Not the one after, the one before. Okay, so my equation, y equals a, which is 3, and b, which is 1/4. So y equals 3 times 1/4 to the x. All right, so that concludes your video on the review for your exponential functions quiz. Good luck on your quiz.